Sathyabama Institute of Science and Technology.
Hello everyone, I'm Dr. Priyadarshini, Professor, Department of Mathematics, Sathyabama Institute of Science and Technology. Today, I will be introducing the topic on regression analysis. What is regression analysis? Regression is the act of going back or regressing back, returning back. The term was first used by Sir Francis Galton in the year 1877 in his paper Regression Towards Mediocrity in Hereditary Stature. He had studied the relationship between the height of fathers and sons for the first time. The line used for describing the tendency to go back is called regression line. We can also use the term estimation line or prediction line. For example, we can take sales and the advertising expenditure. So the more you spend on advertisement, the more sales you will get. So the next one is we'll study about the regression analysis. Regression analysis helps us to estimate or predict the value of one variable from the given value of another variable. The known variable is said to be the predictor variable, or it is also called the explanatory variable or independent variable. The variable which is predicted or estimated is called the dependent variable. For example, if you take the relationship between the blood pressure and the age of a person, we can say that blood pressure is dependent on the age of the person. So the types of regression. What are the types of regression? Simple regression. If it is a study between two variables, x and y, then we call it as a simple regression. If it is more than two, then we call it as a multiple regression. Linear regression. If the regression curve is a straight line, it is called a linear regression. Otherwise, it is said to be a non-linear regression. Now, the regression lines. What are regression lines? These are the graphical representation of the relationship between the two variables. For example, I've given you the relationship between income and savings. So, this is plotted against a graph x and the y, and we have taken the x-axis to be the income and the savings as the y-axis, and we have plotted a line. This line is called the regression line. Regression equations. What are regression equations? These are the algebraic representation of the relationship between x and y. Prediction or estimation of most likely values of one variable for specified values of the other is done by using suitable equations, and these equations are called regression equations. So we have got two regression equations. One is y on x and the regression equation of x on y. So the first regression equation is given by y minus y bar is equal to byx into x minus x bar, where your byx formula is summation x minus x bar into y minus y bar divided by summation of x minus x bar the whole square. This is another formula for byx. Similarly, the regression equation of x on y also can be got. Now, the relationship between correlation and regression coefficients. So, already in the previous video, I have explained about regression analysis. Now, this is the relationship between correlation and regression analysis. Byx is r into sigma y by sigma x, and bxy is r into sigma x by sigma y. So, if you multiply the two regression coefficients, you will be getting r square. So, r is equal to square root of byx into bxy. That means it is a harmonic mean between the two regression coefficients. So, the conclusion is correlation coefficient is equal to square root of bxy into byx. And we have got an angle between, because there are two lines, we come across the angle between the two lines of regression. So the two lines of regression are given by the angle is tan theta equal to 1 minus r square by r into sigma x sigma y by sigma x square plus sigma y square. And particular case, when r is equal to 0, What happens when r equal to 0? You will get it as infinity. Tan theta equal to infinity, so theta equal to pi by 2. So the two lines will be perpendicular to each other. The next case, when r equal to 1, what happens? 1 minus 1 will be 0. So tan theta is 0, gives you theta equal to 0. That means the lines of regression are parallel to each other, or they lie one on another. The next are the properties of regression coefficients. So already I told you the regression coefficients are called as bxy and byx, and the one regression coefficient is greater than 1, then the other one should be less than 1. And they are not independent of the change of scale, and there will be a change in the regression coefficient if x and y are multiplied by any constant. Then this we have already done as a result, that is, a geometric mean between two regression coefficients is equal to the correlation coefficient. If byx is positive, then byx is also positive and vice versa. So this is a problem in which, from the data given below, we are going to find out two regression lines, coefficient of correlation between the marks in physics and the marks in chemistry. Third one is the most likely marks in chemistry when the marks in physics is 78, most likely mark in physics when the marks in chemistry is 92. So you have arranged it as column x and column y. So we'll be calculating x square, y square and xy column, and we'll be taking the total for all the 5 columns. So the next is we'll be calculating our x bar. X bar, as we know, it is the mean, that is sigma x by n will give you x bar, which is 83.6, and similarly y bar is 88. Now we'll find out the regression equation of y on x, which is y minus y bar equal to byx into x minus x bar. So we substituted in this formula, we'll get our byx value. Substituting in the regression equation of y on x, we get y minus 88 equal to 0.949 into x minus 83.6. So the final equation is y equal to 8.6 plus 0.949x. So the regression equation of y on x again is given, x on y is given by x minus x bar equal to bxy into y minus y bar, and this is also calculated using the formula, and we get the value for bxy to be 0.990, and substituting it in the regression equation of x on y, we calculate and find out our x to be equal to minus 3.5 plus 0.99y. Now the correlation coefficient between x and y is square root of bxy into byx, which is equal to 0.969. So the correlation coefficient for this particular problem is 0.969. The next we have to do the most likely marks in chemistry when the mark in physics is 78. We have to find the regression equation of y on x. So instead of this x, we have to substitute 78. So when you substitute 78 in that, we can calculate our y is equal to 73.85. So the mark in chemistry is 82.62. The next one is the most likely marks in physics when the mark in chemistry is 92. For this, we'll use the x on y equation. In that x on y equation, instead of y, we will be substituting 92 and we'll calculate and get our x value, which is the mark in physics, and that is 87.58. Then we'll come to the next problem, which says that there are two lines of regression, 8x minus 10y plus 66 equal to 0, 40x minus 18y minus 214 equal to 0. The variance of x is 9. Then we have to find out the mean value of x and y. Secondly, we have to find out the correlation coefficient between x and y. Now, because the mean x bar y bar passes through the two regression lines, it will satisfy these two equations. So we'll get 8x bar minus 10y bar equal to minus 66, 40x bar minus 18y equal to 214. Now when we solve these two equations, we will get our x bar value to be 13 and y bar value to be equal to 17. So the second subdivision is we have to find out what is the byx and bxy value, because we have to calculate our correlation coefficient. So let us take the first equation to be y on x equation, and we will get 10y equal to 8x plus 66, or y equal to 8 by 10x plus 66 by 10. So that gives you the regression coefficient of y on x to be 8 by 10. Similarly, the second equation, we will take it as a x on y equation. So we will get it as x equal to 18 by 40y plus 214 by 40. So that gives the regression coefficient of x on y to be 18 by 40. So now we have to calculate our R square. R square is nothing but byx multiplied by bxy. So that gives you 9 by 25, and taking the square root of R, we are able to get our R, the correlation coefficient, to be plus or minus 0.6. So we have done an analysis of this regression, and in the coming videos we'll be doing more things in detail. Thank you very much.